Hello everyone. So in this video, what we're going to do is we're going to focus on how would you go ahead and determine the density of a substance given its mass and its volume. So we're going to show how to do it on Google Sheets using a graph. But before I go ahead and start it, on that, let me go ahead and go over kind of the whole idea of why this would work. You'll recall that the definition for density is D is equal to M divided by V, right? Density is mass divided by volume. If I were to go ahead and solve this, or basically what I'm going to do is multiply volume to both sides of this equation, so volume cancels on the right side. Then I get V times D is equal to M. And so all I'm going to do is I'm just going to flip it around. And I'm going to write it as M is equal to D times V. So I rearrange the V and the D. Because remember, if they're multiplied together, you could just rearrange them. 3 times 2 and 2 times 3 are the same thing. I put M on the left side, D times V on the right side. Well, this is in Y equals MX plus B format, because you got one thing on the left, what's on the Y-axis, and if you plot mass on the Y-axis, that's going to be equal to whatever the slope times whatever is on the x-axis, plus b, and in this case, b is 0. And that makes sense because when volume equals 0, mass should also equal 0, right? If there's no volume of something, of a chunk of something, there is no volume, there is none, then the mass should be 0. So your y-intercept is 0. So what we're going to do is we're going to go ahead and plot mass versus volume. And when you do that, I'm going to go ahead and graph this. You put mass versus volume, and you should get a straight line through the points. Or if I put the points in there first, then I put the line through. Whatever the slope is here, that's going to be equal to your density. Okay, and that's what we're going to do. I'm going to show you how to do this using. We could do this by hand, but I'm going to show you using a spreadsheet program called Google Sheets that you could get from the Waffle. All right, you go to Google and you go to the Waffle icon right here, and Sheets is right there, and you'd open up a Google Sheet. Okay, and you hit a blank sheet, open it up, and you're ready to go. Okay, so what we're going to try to do is we're going to try to come up with a graph using Google Sheets here. And so what I have is a Google Sheet. Let me go ahead and show you how you can come up with a graph on Google Sheet. If you've never used a spreadsheet program, like Google Sheets is one example, Microsoft Excel is another. I really like Microsoft Excel because it's very powerful, but Google Sheets is about 90 to 95% of what Microsoft Excel is. So we can use this pretty well also. I've used both of them, and there's others, Lotus 123, which has kind of fallen out of favor, but that was the first one I used. First off, real quickly, what a spreadsheet program is. It's a very powerful program, and if you guys learn how to use a spreadsheet, there's a lot of jobs you can get basically just knowing how to use a spreadsheet. It's different from a word processor in that you'll see that it's broken up into a grid, and this grid is made up of columns that are lettered on top, right? So you got the letters on top, and you got rows on the side. So column C, I'm going to highlight column C right here, and you'll notice that it comes up column C, and column F is right here, and the rows, row 4, I've highlighted right there. Where each column and row intersect is what's called a cell. So this cell right here is in column B and row 4. So we call it cell B4. And sometimes we will call upon that cell when we want to have a number in there be multiplied by something else or divided, or we want to use it in a formula. I use spreadsheets for my household budgets in order to be able to calculate how much I'm going to owe, how much I'm going to have left over, try to make some projections. It's very good for household stuff, business, things like that. And of course, it's really good for science. So let me go ahead and show you how we're going to use this. First thing we're going to do is we're going to go ahead and make a table. So you have your data table, and the data table should look something like this. What you can do is you can go ahead and in each of these cells, you can type in either words, which makes this what's called a string variable. String variable is just when you're using words and letters. Okay. So the first column I'm going to make is trial number. And then I guess I'm going to put the 3 trials on here. So there's trial 1, trial 2, and trial 3. And then the next column I'm going to make is for mass and also volume next to it. So there's a column labeled mass in the C column and a column labeled volume in the D column. Now, one thing I'm going to notice is that, first off, to point something out, these lines right here may seem a little dark. When you get it, they may not be this dark, but I had to basically kind of darken them in, and you can do that by using the borders here. So what I did to the whole thing is I clicked on the corner here, which highlighted the whole spreadsheet, and I turned on the borders. You can turn them off also. But notice that when I do that, especially on the recording, you can't see the graphs. Right now on the computer, I can see the lines. They're faint, but I can see them. But I noticed that on the recording, I can't. This is my second recording, so this I can tell. So what I've done is I've gone ahead and turned on the borders. Let me go ahead and turn it back on again. This little waffle looking thing over here turns on the borders, and you can just go ahead and highlight just a number of cells to turn on the borders, but I'm doing it the whole thing so you can see kind of, I'm accentuating the cells so you can see them, because on the recording you can't. All right, so I'm going to go ahead and put in, not only am I going to put mass and volume, but I want to put that there's specific units for mass and volume. So I have no space here. One thing I could do is I can go ahead and move the trials numbers down, or what I could do is insert a row. And if I click on 3, then right click, it says insert one above, insert one below. You can insert a row, basically. And that's what I did, is I inserted a row above where I had clicked on. Now it added this extra row. Now I can go ahead and under mass, I can put in the row below it grams, because that's my units for mass. And for volume, it was milliliters, so in parentheses, I put milliliters. Notice that I put them in parentheses to show that those are the units, right? That way I know that the volume was milliliters, it wasn't liters, it wasn't quarts, it wasn't cubic centimeters. Well, actually it was cubic centimeters because milliliter and the cubic centimeter are the same, but it wasn't cubic decimeters, it wasn't liters, it wasn't gallons or anything else. Same with mass, it was grams, it wasn't kilograms, it wasn't slugs, it was grams. Then I can go ahead and put my data. And I'm going to use some sample data here. This is not the data from the what you just did, the video you just did. So in my sample data, the mass for first trial was, let's say it was 27.2. In trial 2, the mass was 45.6. 45.6. And in trial 3, the mass was 73.0. Now you'll notice that this comes up as 73. The 0.0 can't be seen. If you want to go ahead and format them, you can go ahead and highlight them all, and then right click and format. Let's see, I'm trying to go based on how you would do it on Excel, because I'm much better at Excel. You know what? Go ahead, highlight them all. There's a format button up here. Click that, and then you go to the number, and it'll tell you, it'll ask for how many decimals you want. So you go to number, you can go right here, decrease the decimal places. So it'll show the decimal places. So here is a shortcut right there. You want more decimal places, you can increase here till as many as you want, and then you right next to it you can decrease the decimal places. We're just going to go to 1 because that's what we had. I tried 73.0 and automatically got rid of the 0, but if I want to show a certain number of decimal places, I can. Okay. Yeah, pardon me, because I'm used to doing it one way in Excel, and it's a little different on this one. The volumes were for trial 1 15.0, for trial 2 25.5, and for trial 3 was 43.2. Okay, so that's your data. And once again, you can go ahead, I mean, I think you can do this even with just one. You can go ahead and increase the number of decimals. There you go. So this was the only one that needed to increase the decimals. So there you go. Later on, we can actually make this even bolder so we can make a table, but I'm not going to worry about that right now because right now we're worried about getting a chart going, okay, or a graph. Okay. So now that you have your data in a table, now you can go ahead and turn that into a graph. And remember, what we're trying to do here is we're trying to use our y equals mx plus b function in order to figure out the slope of the graph, because the slope is a density. How do I get that? Well, you'll recall that from earlier that d equals to m divided by v can be turned into m is equal to d times v. So right here, m is equal to d times v. And so this is in the format of y equals to mx plus b. A number is equal to two numbers multiplied to each other plus 0, where b would be 0 here. And so if you have values for mass and values for volume, if you plot those, then the slope of that would be density. Right? That would be your m right there, or your slope, I should say, because there's an m in here that's on the y-axis, although that's m for mass, not m for slope. It's a little confusing that way when the mathematicians use m for slope, but they've been doing that since at least when I was in school. All right, so let's see how we can come up with the graph. In order to do the graph, what you do is you go ahead and go up to Insert. I think the good way of doing it is to highlight the data that you want used. Then go up to Insert, and you can insert a chart. So you'll see down here, charts are what you're going to use. And when you click on that, here it comes. There's a graph. And luckily, it got the right chart type. Okay. Just to let you know, this here on the right side is the chart editor. And the chart editor is how you can change things on the chart. And we're going to have to change a few things, because what the program does here, it tries to guess what you want. But sometimes it doesn't guess right. A lot of times it'll come up with the first crack will be a bar chart. And right now, a bar chart's really not going to help us. We want one that gives us a line chart. That gives us a line. What we want is actually, we want a scatter chart. So if you look over here, scatter is right here. Scatter chart. Don't get confused with the line chart. There is a thing called the line chart right here, and a lot of times people go, well, we need a line, so we should do a line chart. If your data is not in the correct order, then the line chart's not going to put the numbers in the correct place. You know, if let's say your X data was not like from smallest to largest, it's not going from like 2, 4, 6, 8, 10, but maybe your first data point started with X value of 8, second data point was 4, third data point was 10. It will put your X's in that order. 8, 4, 10, whatever that. So line chart is not good for this, okay? A scatter chart will put 8 where 8 belongs, 10 where 10 belongs, and so it will put the X values correctly. It'll put the Y values correctly in numerical order where they belong. Also, the line chart's not going to space them correctly. If you go from 2 to 10 to 20 to 100, it's not going to space them correctly. It's going to put 2 next to 10, next to 20, next to 100. They're going to be equally spaced. So you want scatter chart. Right? So here we have a scatter chart. Now, this scatter chart, I can move this out of the way. Just you can go ahead and click on it. I'm just trying not to click on any of the elements. And you can move it out of the way of the data here, and then move this up and down here, okay, using this bar. And you'll notice that it has a title. It says milliliters versus grams. The way it's set it up, if you look over here on the chart editor has two main submenus, setup and customize. So setup is the main setup. What's on the x-axis, what's on the y-axis. The data range, you've heard that range is the x values. So your data range, well, actually it's got that the data range is C4 to D6, but on the x-axis, what it's doing is it's putting C4 to C6, which is, if we go back to the chart, C4 to C6 is your mass. We don't want that on the x-axis. We want that on the y-axis. So I'm going to put this on top here to remind you that we want mass to be on the y and volume to be on the x. Because remember, from our equation over here, m is equal to d times v. So density is going to be multiplied by volume. So volume has got to be the x. Okay. Now you'll notice that when I went here to the the spreadsheet to plug in x above the mass and I'm sorry, y above the mass and x above the volume, my editor went away. If you wanted to come back, just go into the graph and double click over here. And when you double click, the chart editor comes up. So I'm still on my setup. So go to setup, click scatter chart, go down the x-axis and choose D4 to D6 because that's where the volume is, right? You want the volume to be on the x-axis. So this is D4, this is D5, and this is D6. You want those to be on there. And so when you go to the chart editor and you go to the setup, x-axis should be D4 to D6. That colon right there between these C4 and C6. C4 and C6 are the are two of the cells, right? C4 is in column C, row 4. C6 is in column C, row 6. So if you click on that, it gives you the option of D4 and D6, or you can type it in. Right? Whenever there's a colon, it means everything in between those two. So D4, D5, and D6 is basically what it's saying right there. Okay. So now you've put your volume on the x-axis. Now we need to tell this thing to put the mass on the y-axis. So you go to series. And the reason why I said series is because you can plot several different things versus the same x-axis. So you could have put volume and maybe put temperature. You maybe got some data for something else. You can actually do 3, 4, 5 lines here, different things. Usually that's just one line. And so for the series right here, we want mass to be on our y-axis, and mass is in C4 to C6. So we're going to click on that. Okay, so x-axis, you can have D4 to D6, or wherever you might be, wherever you start your table. Find out where the numbers that you want to go on the x-axis are, and that's where you put an x-axis. And find out where the numbers that you want the y-axis to go, that's where you put for series. Okay, and then you're done with the setup. Some of the basic setup. And so here is your line. Oh, one other thing. One thing I forgot to point out is that on something like this, we do know another point, and that other point is that this thing goes through the origin. So 0, 0 should be a point on our line. And so since 0, 0 is a point on our line, I've gone ahead and included those. You probably should have included that before you did the range, but luckily it kind of guessed. Sometimes this program tries to guess and it guesses right, and it did here. So by doing that, once again, I got rid of my chart editor. It disappeared. So I go ahead and double click back on it. Okay. So now we've got our points on our graph, right? And you'll notice that we have numbers here, and these are grams and milliliters. If you go to customize, so that's the setup. The customize here kind of tells is where you're going to go ahead and be able to write things out. Remember, what's important on every graph should have is a descriptive title, and by descriptive, I don't mean something snappy or something witty. This is science. All we want is what's on the y-axis versus what's on the x-axis. Okay, so your chart title will generally be whatever you've got on your y-axis versus whatever you got on your x-axis. You can put a subtitle in case there's you want to emphasize something else, but you need to do that. And your x-axis and your y-axis are also going to have to be labeled so that people know what is on the y-axis, what's on the x-axis. So if you go here, chart, you'll notice right here, chart style we've already taken care of. That's already been set up. I don't think it really matters a big deal. You can change the background color, the font, all kinds of other stuff, border colors, whatever. We're interested in the chart and axis titles. And we were going to start off with is the main chart title. On this chart title, we've got mass on the y-axis and volume on the x-axis, correct? So that's what we're going to write. We're going to write mass versus volume for, let's say, liquid A. Let's say that we're going to do this for liquid A. Okay. So there's your title. We can change fonts if you'd like. We can make the font bigger. Let's make it bigger. I guess we'll go 20. I don't know if that made it any bigger. I don't know what the default is. Make 24. You can center it. I think for a title, it's good to center it. You can even change the color. Let's say we want blue. You can do this for all the titles. Okay, so for the chart title, we've got that. You can even do a subtitle here. Right now there is no subtitle, but I'm just going to put in subtitle in the interest of time. I'm not going to think of something snappy. And whatever you did for the auto title, you can also do for this one. I'm going to center it. You can change the color. I'm not going to. Let's say I want to bold it. All right, so you can see it better. All right, so there was a chart title, chart subtitle. Horizontal axis is your x-axis. And what we put on their x-axis was volume. So I'm going to go ahead and put that. That was volume, and our units were in milliliters. So on your axes, you put what was on that axis, what was the quantity that was measured, and what were the units in parentheses. That way we know it's volume, and we know it's not gallons, it's not liters, it's not cubic decimeters, it's milliliters. Okay, so go ahead and type that in on the horizontal axis. These are things that a good graph always has. The main title and the axes are labeled so that someone could look at this and go, oh, okay, this is what we're comparing. That's all you need for a horizontal axis. Once again, you can go ahead and change the color of the font. You can change the font size, the title font, I don't know. You can change the type of font, I guess. It's the same thing for the vertical axis. You go to the vertical axis title, and you put in what's on the vertical axis. And here we had mass, right? And it was in grams. It wasn't in kilograms. It wasn't in slugs. It was in grams. And you can decide to bold it or not. Let's bold it. I'm going to go ahead and even for the horizontal title, I'm going to bold it. Okay. So these are the things that you can have to make it readable. Okay. So although I'm not very big on making things look cute, I am big in making them look readable and have things kind of coming out. Okay. So you've got your main title, Y versus X for for liquid A. We're going to do another one for liquid B later. Then on the y-axis, the mass is in grams. Very important to put your units. I see so many graphs turned in by students don't have units, so I have no idea what they use for their units. And x-axis volume and in units also. So now this is not what we're what the main reason is for doing all this, right? This is it's nice to have a graph, but there's a reason why we're graphing. We want a slope. And so what I'm going to do, moving this down a little bit, I'm going to make this a little bit bigger. So what we want to do is we want to put in a best fit line, also known as a trend line on these things. We want to put a best fit line through these points. So what I'm going to do is I'm going to go ahead and close up the chart and axis titles. Right? So these are all the little sub things. You can change all kinds of stuff on here. Put a legend. You can format the horizontal axis to vertical axis. Well, what I'm interested here in order to get the line is the series button. All right, so basically the series, there's only one data series on here, so we don't have to worry about it. If there was more than one, if you're graphing more than one thing versus the x-axis, then you'd have to pick your data series. But since there's only one dependent variable, basically a data series is the dependent variables. Since there's only one set of dependent variables, then that's what we're going to use. When you click on series, it's set to data series 1. You can change the color here if I want to change this to red. Now my dots are red. If you want to put the numbers on the right side of the axis, you can, although sometimes you've seen graphs where there's two series and some of the numbers on the right, some are on the left because the numbers are way off. They're different scales. Point size, when making bigger or smaller, you want to make the shapes different. You want a triangle, you want a star, stuff like that. You can change all that stuff. There's a whole bunch of stuff to this program. But the only thing that I really care about right now, as we go through this series right here, is this right here, trend line. If you click on this, it turns on a trend line. And basically that's the best fit line through all the points. The points may not necessarily be in a straight line exactly, but it's the best line that fits through all of them. And there's actually a mathematical calculation that you can do, but you don't normally learn this until you take statistics in college, as to how you can get the best line through certain points. So normally we just kind of eyeball it when we do it by hand, but here it's using this line was calculated using some statistical methods, some equations that we get for the trend line. And then in order to figure out the slope, which is what we want, you want to have the equation of the line, right? So you go down below trend line, you go down where it says label, right here, and right now it says none. You can go ahead and label and it says use equation. When you click use equation, the equation of the line appears right here. So this should be really y equals to mx plus b. Really the b should be 0, but it's a little off, no big deal. That's what I like about Microsoft Excel. You can actually force it through 0, but this one I haven't figured out yet. But here's the slope, 1.69. So that's your slope of this line. And since we know that the slope of this line is the density of the substance, then we know that this is the density. 1.69 is the density. And since our units here on the y-axis are grams and the units on the x-axis are milliliters, that means that our density is 1.69 grams per milliliter. Okay. So that is how you can go ahead and get the graph that will give you the density. You plot mass versus volume, mass on the y-axis, volume versus x-axis, make the graph, and then you go ahead and add a trend line. When you are done, you can turn this in by going ahead and highlighting the whole thing. So let's go ahead and highlight the whole thing. Everything, the graph and the data. Oops, I don't think I'm going to get the whole thing if I don't. Highlight so that your data table and your graph are all in the highlighted area. Then you come up to, where was that? Oh, no. You go up to File, Download, PDF Document, and it's going to give you a PDF. And since we highlighted all of the grids, the current sheet goes for miles and miles and miles. Right? Everything that has, and it could probably go further. So what you want to do is export just the selected cells, just the ones that you highlighted. So you see just your data and the graph. And you can make it fit to, this one's fit to width, you can make it fit to page. So it fits in one page. Okay. And then, once you do that, you export it. When you export it, it gives you a PDF of your graph. I open that up, and here's a PDF that I can name, download, name, and then submit. Okay. And you'll have one for liquid A and one for liquid B, and you can either combine the two because there are programs online that allow you to combine, web pages allow you to combine PDFs, or you can, I guess, submit them individually. Okay. All right, so hopefully that was helpful to you guys. If there are any questions, I realize I went through this really quickly, but if there are any questions, let me know. I really like it when my students learn how to use spreadsheets because they are very powerful applications to learn how to use. If you can learn how to use a spreadsheet, you can do a whole bunch of stuff real quick. Believe me, there's a lot of labs where you have to do a bunch of calculations by hand. And if you know how to use a spreadsheet and you learn how to use, let's say, a formula and then copy and paste that formula, the calculations are done for you in a snap. Okay, so there's a whole bunch to do with spreadsheets. So this is supposed to be part of this kind of lab that we're doing with density and mass and volume. I had a deadline for watching the video, but the deadline for turning this in, I'm going to leave it loosey-goosey. You've got a quiz on Tuesday, and I understand that you want to kind of focus on that. I want you to get a chance to kind of work on this, ask questions. So I'm not exactly sure if I'll have you turn it in Wednesday or Thursday, sometime next week, but I'm still leaving it a little open-ended until I can get an idea if everybody's getting it or not. Okay, this is kind of a simple graphing, but if it's your first time using it, there's a whole bunch of stuff to put together. So I'm taking my time with it. All right, so hopefully this was helpful. If not, see me and I can go over, I can probably answer questions so you can then learn how to use this program that works for chemistry but works for a whole lot of other stuff too.